This is part 2 of my series on how to stay safe for free in this digital world. First video was on the most important step to protect yourself online. If you haven't seen it yet, you definitely should. After watching this video, link could be down in description. In this video, I'll explain how to protect your data for free from prying eyes. Now, this can be intellectual properties, starting from code, articles, and even text that you want to hide from your government. China. It can even be pictures and videos from your boo or boos that you don't want anyone else to see ever. So, how do you do it? Simply by encrypting it, so only you can see its content. For a single file, you may choose something basic, like protecting it with a password within the software itself. I believe PDF and Word documents can be protected in such way. Now, those are quite easy to circumvent, and additionally, it's often multiple files that needs protecting. To be fair, modern operating systems do support this. In Windows, there is BitLocker. In OS X, we have File Vault. Linux has similar experience using TPM tools. But all this come with the same issue for me. What are the backup options? I don't even trust my RAID NAS drive, let alone a normal hard drive. Please understand, these are mechanical devices or flash drives, and they do eventually wear out. Please don't trust a single device to hold your precious data. What do? I have backups of my backups. In my case, it's all my coding, photography, electronic works, and blueprints for over 25 years. From earlier backups that were in floppy, upgraded to zip drive, then to CD, and then DVD. With OS-based encryption, that doesn't work. On top of that, when I'm at home, I work on my desktop PC running Windows 8.1. When I'm away from my home, I work on my MacBook Pro. At times, I have codes running on Pi or NUC devices that are Linux based. So what we need is, number one, a seamless experience where all the encryption and decryption is automatic. Imagine you're working on a document that is protected. Obviously, you don't want the added responsibility of encrypting it each time you save it. No, you just want it to happen. Number two, it needs to be cross-platform. So you can use your encrypted data with any operating system without compromising it. What I mean by that is, opening your encrypted files in Windows, copy decrypted files to a flash drive, and then taking it to a Mac. That is not what you want. Finally, the most important part. There is a lovely XKCD strip to segue into it. As a nerd, I can talk about the entropy and how long it would take a supercomputer to break the encryption, where a bad guy would just take a wrench to my knees. So how do we solve it? Imagine having a special safe. With one combination, it opens to one compartment, and with a second combination, it opens to a different compartment. And obviously, as an end user, one cannot tell the difference. If I had £1 million to hide, I would put 90% of it in the main compartment and the remaining 100,000 in the other. So if there was a wrench or a baseball bat involved, I would give them the second combination and hopefully save my kneecap and 90% of the money. That's the idea. You have your protected files in one place and some files that you don't care about in another part. Thankfully, this is again seamless. Before jumping into the software, let's talk about the actual authentication. How do you access your protected files? Let's start with the concept of password. I have explained it in details on my first video, so instead of rehashing myself, here is part from that. Suppose you create a password following all the common guidelines. So you include both lowercase and uppercase alphanumeric characters with symbols if permitted. You avoid character or word repetition, keyword pattern, letter number sequence or dictionary word, regardless of language. You don't use anything associated with you in any way. With all that in place, to crack AES 256 without any additional layer on a semi-fast computer, a 7 characters password ABCDEFG would take 0.29 milliseconds. An 8 character password ABCDEFGH would take 5 hours. A 9 characters password ABCDEFGHI would take 5 days. A 10 character password ABCDEFGHIJ would take 4 months. An 11 character password ABCDEFGHIJK would take a decade. A 12 characters password? Well, ABCDEFGHIJKL would take 2 centuries. Now, those values are all relative to computing power, but you can see the magnitude it changes by. That above calculation is based on an encryption known as AES, but it's true for most modern encryption. So obviously you should use a good password. There should be another image about password courtesy of XKCD. So, what do? Well, we are talking about my whole life's work here. I don't want only to rely on a password. I want to make life hell for whoever wants to look into my files. Say hello to KeyFiles. Think of a KeyFile as a file with a bunch of letters, just like a password. But this can be much longer, as you don't have to type it in. My recommendation for a minimum length would be 64 characters. But as someone can just take it and use it, we need to use a password as well. What did it achieve? Well, for someone to brute force it, now they're looking at a 64 characters long key plus my main password length. We are not done yet. We are talking about my whole life's work here. Now, I can't tell you exactly what I do, obviously, but I will give you some hints. Number 1, you can have multiple keys. And number 2, any kind of file can be a key. I've been using this method for over 15 years. Initially, I used a software called VeraCrypt. Then all of a sudden, one day in 2014, something strange happened. VeraCrypt official website started redirecting visitors to SourceForge with a truly cryptic message. See what I did there? It's a story worth a video by itself. Long story short, from that aftermath arrived my recommendation, say hello to VeraCrypt. Built on VeraCrypt, VeraCrypt has further external audit performed to ensure the software is indeed what it is claiming to be. So let's begin. I'll show you the process in Windows, but the same process is true on all platforms. Once downloaded, process to install it for your system. I have downloaded the portable version, which means I can copy the files and run it from a USB drive if necessary. And I prefer portable when possible. Once we run it, we are presented with the main window. First thing we need to do is to create a container. You have a couple of options. The geekiest method is to encrypt a whole partition. If you don't know what I'm saying, ignore it. If you don't know it, you don't need it. Next option is to encrypt an external drive, which is great if you travel with an external drive with sensitive data. Something Randy Pitchford, CEO of Gearbox, should have heeded before he accidentally left a selection of allegedly underage pornography on a USB stick at a restaurant. In our example, we'll look at a single file method, as this is the way we can keep backup to other media, i.e. burning it on a DVD and such. Next, we select Hidden VeraCrypt Volume. This is the feature we talked about, the hidden compartment. Then select Normal Mode, as we are creating a new volume. For existing volume, we would be selecting Direct Mode instead. Select the file. Note, though it says select, we are really creating a new file. So please don't select an existing file here. Give it a name with any extension you want. Then we get to the volume creating wizard for the outer volume. we get a bunch of options to select encryption and hash algorithm. A bird's eye view: encryption is used to protect your data, and hash is used for random number generation, which we'll come across soon. Default encryption is set to AES. Now, it is not the best algorithm in the list, but it is still super secure, and more importantly, most modern computers can encrypt and decrypt AES in hardware, which makes it much faster. I would stick with it and SHA-512 for hash. Then volume size. Note that this is the main container that would hold both real and fake data. In our example, we'll go with 100 meg and split it 50-50 for both sections. For the outer volume, i.e., the one we would reveal if we're forced to, I just use a password for this and no KeyFile. Note, in this example, I'm using Rana outer. You should at least use a real looking password. Yes, you shouldn't be seeing the warning message either. For file system, go with exFAT. That is supported on all platforms and bigger size limit than FAT. If you know what cluster size is, feel free to change. Finally, we need to move our mouse to generate randomness. Once done, format the volume. VeraCrypt will ask you to open the outer volume to copy some sensitive looking data. Then it will use that size to determine how large the hidden compartment can be. You can always do this later by opening the outer volume, in which case you will need to ensure Protect Hidden Volume Against Damage Caused by Writing to Outer Volume is checked in Mount option. Now we have the wizard for hidden volume. With a size of 50 MB, this time we will use KeyFile. Clicking the KeyFile would allow us to add existing files or to create new ones. Let's generate a random KeyFile. Now, true random is almost impossible in real life. In computers, we have to use pseudo-random, which itself is a can of worms. This is probably the best way to generate randomness for most people who are not hooked to a lava lamp. Yes, that is one way to generate randomness. Finally, format the volume. All done, we can exit the wizard. Now let's discuss use case. This might be protecting something that you'd open at an ad hoc basis, or there might be times you might want it to auto-start on login. Well, first ad hoc. We need to mount that container we have created to a drive name. This main window shows us available drive letters, so we just need to choose one and select our file. If we had encrypted a partition on a drive, we would be selecting device. Finally, pressing mount brings up our authentication window. We have used password and key files, so we need to link that by choosing key files. Note the option cache passwords and key files. Suppose you mounted your files and after working on it, you decide to unmount it, i.e. not available to the system anymore. Later on, if you want to open it again, you will need to redo this process, unless you have cache checked. In that case, VeraCrypt will remember the last 4 successful mount until exit. With mount options, you can set up additional feature. In my use case, I have couple of containers, all with different key. All those keys are then in another 1 MB container that is in cloud. Content of this cloud container doesn't get changed very often, and to be safe, when I open it, I open in read-only mode. So nothing gets changed and it doesn't have to resync in cloud. Once mounted, you have a drive that you can put whatever you want, however you want it. Everything you copy into it or edit is automatically encrypted and protected. Right-click on the mounted line would give you additional features like check, repair, and add to favorite. You can use it to remember the settings and even mount on login. This is how you would auto-load on boot. Personally, I would stay away from it, as security of any system is as secure as the least secure part of the system. I know that's a mouthful. So if you're using a very simple Windows password or no password, auto mount is basically not having any protection. Once you're done, you should dismount just to be safe. VeraCrypt also supports smart card and fingerprint device, but as most of us don't have one, I'll skip it. One additional tip: if possible, have Use Secure Desktop for password entry checked in preferences. That will make it difficult to sniff password. Well, that's all for this video. I hope this will help to protect your data and to do it for free. I have linked VeraCrypt in description. This is not a paid promotion and solely from my own experience. If there is enough interest, I will continue this series with more ways to ensure you're safe online for real. If you have liked this video, please give me a thumbs up and maybe leave me a comment to feed YouTube algorithm. If you dislike this video, please give me a thumbs down and maybe take your time to tell me why in the comments. You will find similar contents in my other videos. If you want to be notified about any future videos, subscribing would be a good idea and would help this channel grow. That's all. Have a safe day. Signing off.